Assalamu alaikum. So now we need to practice the questions from past papers, and the first question that has been taken is from year 20, May, June, and its variant 2. So the question says the equation of a circle with center C. So I have the equation of the circle, center C, it's x square plus y square minus 8x and plus 4y minus 5 is equals to 0. So we need to find the radius of the circle and the coordinates of the center C. So if I draw the circle here, then with respect to the circle, what we know is that there is the center with, let's say, the coordinates x and y, and we have the radius. Let's say the point is P and this point is x, y. This point has coordinates x and y, and C, the center, has coordinates A and B. So if I need to find the radius as well as the center, I know that the equation of the circle is represented by x minus a the whole square plus y minus b the whole square, and this is equals to radius the whole square. So the equation that is given to us, if I bring it to the form so that it is x square minus 8x plus y square plus 4y and a minus 5, which is equals to 0. I have left some space because I know that I have to bring it to the form of a minus b the whole square to get the central coordinates of the circle. So to do that, I will be doing it by completing the square method, and for that I know I have to divide the coefficient of x, which is 8, by 2. This would give me a 4. Therefore, the next step is to add and subtract 4 the whole square to the equation. So adding and subtracting 4 the whole square to the equation, balancing the equation, this is what I will be having here. So this is the work that I have done, the extra work that has been done to bring it to the form of x minus a the whole square. In the same manner, I will be taking the coefficient of y, which is a 4, and divide it by 2. That gives me a 2. That means I should be adding and subtracting 2 the whole square to the circle here. So that means it should be a plus 2 square and a minus 2 the whole square. So again, this is the additional work that I have done to bring it to the form of y minus b the whole square. So from here, I can say that if I take the first 3 terms, I can say this is x minus 4 the whole square plus y minus y plus 2 the whole square, y plus 2 because the coefficient of y has the sign positive, therefore it's a y plus 2, yx minus 4 because the coefficient of x has the sign negative, therefore this is x minus 4 the whole square. Then I will be taking the constants on the other side, which is negative 4 the whole square, negative 2 the whole square, and negative 5, which was already there in the equation. So from here I am left with x minus 4 the whole square plus y plus 2 the whole square and a minus 16 and a minus 4 and a minus 5, which is equals to 0. Or I can say this is x minus 4 the whole square plus y plus 2 the whole square, and this is equals to a 25. Or solving it further, I can say this is x minus 4 the whole square plus y plus 2 the whole square, which is equals to 5 the whole square. That means the center of the circle is 4 and a negative 2, and the radius shall be equal to a 5. So this is how I will be getting the center coordinates as well as the radius of the circle here. The second part, the point P1, 2 lies on the circle. So again, if I just draw a small circle, I know the center. The center is 4 and a negative 2. And there is a point P which is 1, comma 2. Let's say that point is here. Point P, 1, comma 2. And we have the radius to the circle, r, which is equals to 5. And show that the equation of the tangent, so I have the tangent also at point P. So this is the tangent, and we know that radius and tangent are perpendicular, therefore I should be having a perpendicular sign. Now with that, I know that if I get the gradient of CP, with coordinates of C being 4 and a negative 2, and coordinates of P given as 1, comma 2, I shall be getting the gradient of CP, which will be equal to the y coordinate of P minus the y coordinate of C divided by the x coordinate of P minus the x coordinate of C, or here I can say this is 2 minus 2 divided by 1 minus 4. Gradient of CP comes out to be negative 4 by 3. Radius and tangent being perpendicular to each other, radius and the tangent, meaning CP and the tangent, they are perpendicular to each other. Therefore, I know the relationship that the gradient of the tangent should be equal to the negative inverse of the gradient of CP. That means this gradient should be 3 by 4 here. So I have the gradient of the tangent, which is a 3 by 4. To get the equation of tangent, I will be using the straight line equation, which is y minus y1, which equals the gradient times x minus x1. I have the point P which lies on the tangent, 1 and 2. I have the gradient of the tangent, which is a 3 by 4. Substituting that, it becomes y minus 2, which is equals to 3 by 4, and x minus 1 here. So solving it further, I should say that this is a 4 times y minus 2, which is equals to 3 times x minus 1, or I can say it is a 4y minus 8, which is equals to 3x minus 3, or it's a 4y, which is equals to 3x minus 3 plus 8, or it's a 4y, which is equals to 3x plus 5, and this is what we wanted the equation of the tangent to be. So this is shown. The coordinates for the center was 4 and a negative 2. Point P had coordinate which was 1, comma 2, and PQ is parallel to the x-axis, meaning it has to be a horizontal line, meaning this is one other point where Q lies. So I know very well that for Q it should be having the x coordinate and the y coordinate that would remain the same. So I have, as PQ lies, as Q also lies on the circle, and I do have the circle equation, which was x minus 4 the whole square plus y plus 2 the whole square, and this was equal to 5. I know the y coordinate, which was a 2. So substituting that, this is 2 plus 2 the whole square, and this is equals to a 25, or I can say this is x minus 4 the whole square, which is equals to 25. X minus 4 the whole square plus 4 the whole square, that would give me a 16, and this is equals to 25, or x minus 4 the whole square giving me 25 minus 16, that's a 9. I can say that this x coordinate is x minus 4 the whole square, which is equals to, I can say it's a plus minus 3 the whole square. The square gets eliminated, and further I can say that this is x minus 4, which is equals to a plus minus 3. meaning x can be equal to a 3 plus 4 or 3 plus 4, or we can say x is equals to a minus 3 plus 4. So x will be equal to a 7 or x will be equal to a 1, which was already the coordinate of P. So here I can say that Q has coordinates which is 7 comma 2 here. So this is going to be the answer. So the tangents to the circle at P and Q, they meet at T. Find the coordinates of T. So the tangent at P and Q, they are meeting at a point Q. So that means if I just make the circle again to understand what is happening here. The tangents to the circle at P and Q meet and T. So we have the diagram in front of us. From point P, there was the tangent for which we already found the equation as 4y equals 3x plus 5. Q, another tangent, and they are meeting at point T. Q has coordinates 7 comma 2. I know that if it is a tangent, then it has to be a perpendicular to the radius. Therefore, the tangent at CQ has to be perpendicular to the gradient to the point CQ, and the gradient of CQ shall be the negative inverse of the straight line QT. So if I get the gradient of CQ, it should be equal to 2 minus 2 divided by 7 minus 4, and this shall be equal to a 4 divided by 3. So the gradient here is a 4 by 3, therefore the gradient of QT needs to be negative inverse, meaning it should be a negative 3 by 4. So Q has coordinates 7 comma 2. The gradient of QT is equals to a negative 3 by 4. So I can get the equation of QT. That would be equal to y minus 2, y minus y1, therefore y minus 2, which is equals to the gradient negative 3 by 4 and x minus x1, which is x minus 7 here. So with that, this equation becomes 4 times y minus 2, that equals negative 3 times x minus 7, or it's a 4y minus 8, which equals a negative 3x plus 21. Or I can say it's the 4y, which is equals to negative 3x plus 21 plus 8, and 4y is equal to negative 3x plus 29. So this is going to be the equation of QT. I have the equation of PQ, equation of PT, which was 4y equals 3x plus 5. So if I equate both of them, I shall be getting the coordinates of t. That means I should say it's a negative 3x plus 29, which is equals to 3x plus 5, or I can say it's a negative 3x minus 3x, which is equals to 5 minus 29, or it's a negative 6x, which is equals to a negative 24, or I can say that the x coordinate is 24 divided by 6, giving me a 4 here. So I have the x coordinate, which is a 4. So to find the y coordinate, simply substitute this 4 in any of the equations. Doing that, I can say it's a 4y, which is equals to 3x plus 5. I'm using PT. So y then will be equal to 3 times 4 plus 5 divided by 4. Or I can say it's y, which is equals to 12 plus 5 divided by 4, or it's a 17 divided by 4. So I can very well say that t has coordinates 4 comma 17 by 4, or it can be written as 4 whole 1 by 4. So this is what the answer for this question is going to be. So this question is from Winter, year 21, and variant 2, paper 1, and this is question number 12 on circles. So the diagram is given to us, and the diagram shows the circle with equation x square plus y square minus 6x plus 4y minus 27 is equals to 0. And there is a tangent to the circle at the point P, which is 5 comma 4. So we can see the tangent, which is APB, and the tangent to the circle at P meets the x-axis at A and the y-axis at B. So find the area of the triangle AOB, where O is the origin. So one thing is very much clear. Point A lies on the x-axis, meaning it has its x-coordinate, but the y-coordinate is 0. Point B lies on the y-axis, so that the x-coordinate is a 0 and it has the y-coordinate to it. And we have the circle equation. So the mind mapping is, first we have to have the tangent equation, and to get the tangent equation I need the gradient, and for that I know that if it's the center of the circle lies here, then the radius and the tangent, they are perpendicular to each other. That means I should be having the center coordinates. P coordinates are already there as 5 comma 4. I should be having the center coordinates, with the help of which I should be getting the gradient, and then with that gradient I will be having the gradient of the tangent as the negative inverse of it. So this is going to be the mind mapping for the tangent equation. So let's start the working here. We have the equation which is x square plus y square minus 6x plus 4y minus 27 equals 0. We have this equation rearranging so that all x's are together, leaving some space for the term that we need to add. It's a y square plus 4y, leaving the term for the y term that we need to add to make it a perfect square and to apply the algebraic identity. Minus 27 is equals to 0. So following the steps, I should first divide 6 by 3, which is the coefficient of x, 6 by 2 to get a 3. So I will be adding a 3 square and I will be subtracting the 3 square also. The 4 here should also get divided by 2, and when I do that, it's 4 divided by 2, that gives me a 2. So I should say it's a plus 2 the whole square and a minus 2 the whole square. So the first 3 terms here and the first 3 terms with y, they are giving me the algebraic identity, so that I can write them as x minus 3 the whole square. The x term, the second term was a negative, therefore I am having x minus 3 the whole square plus y plus 2 the whole square, again because the coefficient of y is a positive, and then I should be taking the constants on the other side, so that it is minus 3 the whole square giving me a 9, minus 2 the whole square, that's a 4, and then I have a minus 27, which is equals to a 0. So I can say that this is x minus 3 the whole square plus y plus 2 the whole square, and a minus 9 minus 4 minus 27, that would give me a minus 40, and this minus 40 would then be equal to a 0, meaning it's x minus 3 the whole square plus y plus 2 the whole square, and this is equals to a 40 here. So I have the coordinates of the center of the circle, x minus 3, changing the sign, this is a 3 and a negative 2. This is the center, and radius I can say is under root 40 here. So I have the center coordinates. Now with respect to the center coordinates, now I can see that my center coordinates are 3 and a negative 2. It's 3 and a negative 2 here. So I can get the gradient with P as 4 and C as P as 4, 5 comma 4, and C as 3 comma negative 2. I can get the gradient of PC, and I can say that the gradient is a minus 2 minus 4 divided by 3 minus 5, or it's a negative 6 divided by negative 2, or I can say that the gradient value is a positive 3, meaning the tangent which is perpendicular to PC shall be having the gradient as the negative inverse, which is a negative 1 by 3. Now P was the point which was present on the tangent with coordinates 5 and 4. So equation of tangent can be y minus y1, which is equals to the gradient times x minus x1, or I can say it is y minus 4, which is equals to the gradient negative 1 by 3 and x minus x1, meaning it's an x minus 5 here. So this is the equation of tangent that I can have. So I need the coordinates of A and B. For A, we already know that the y coordinate is a 0. So for A, my y coordinate is a 0. Substituting that in the tangent equation, I will be getting the x coordinate, and I will say it's a 0 minus 4, which will give me a negative 4 divided by negative 1 by 3 and x minus 5. The negative on both the sides gets simplified. This is 12, which is equals to x minus 5, or I can say that the x coordinate is 12 plus 5, giving me a 17, meaning A will be having the coordinate as 17 comma 0. For B, it lies on the y-axis, therefore the x-coordinate is 0. So in the tangent equation, I will be substituting x as 0, y minus 4 equals negative 1 by 3, and it's a 0 minus 5, meaning it's y, which is equals to a 5 by 3 and a plus 4. So I can say that the y-coordinate here should be equal to 5 by 3 plus 4. That would give me a 3 fours a 12, and 12 plus 5, that's a 17 divided by 3. So B should be having the coordinates as 0 comma 17 by 3. So A and B, they have the coordinates. The question says find the area of the triangle AOB where A is the origin. So if I just redraw the diagram here with A as the origin, with A on the x-axis, O as the origin, A with coordinates 17 and 0. We have the origin here, obviously x and y axis perpendicular to each other. B with coordinates 0 and 17 by 3. So that means that for right angle triangle, the area is going to be half into base, which is OA, into height, which is OB. Substituting the values, it's 1 by 2 into OA, which is a 17, and OB, which is a 17 by 3. I shall say that my area is going to be 17 square divided by 6, which comes out to be a 48.17 unit square. Or giving it up to 3 significant figures, I should say it's a 48.2 unit square. The second part of the question says that PQR also lies on the circle such that PQR is an equilateral triangle. So find the exact area of the triangle PQR. Points P and Q also lie on the circle. So we already have P. QR is an equilateral triangle. So find the exact area of PQ and R. So PQR making an equilateral triangle, that means the figure that I have, they have already given us the points PQR. This is the triangle that we shall be having in the diagram. And with respect to this triangle, they are saying it's an equilateral triangle, so all the sides are equal. And if all the sides are equal, the other thing that we know is the angles, they should be representing 60 degrees here. And they want us to find the area of this triangle PQR. Now, how to get the area of this PQR? Simply, if I redraw the diagram here, it's the center and we have the radius here, which is under root 40. And this is point P. Let's say it's a 5 and a 4. We have point R here and we have point Q here. So we have the radius as under root 40. We know that the angles, they need to be 60 degrees each, 60 degrees each. So if I just draw the radius from the center up till the three vertices, what I can see is that PCQ will be equal to PCR, the area of PCQ will be equal to PCR and also QCR. That means if I should be able to get area of one of the triangle, let's say I want the area of PCQ. So for PCQ, I'm getting this area with P. This was the radius under root 40. Q lies on the circumference. So from the center, the radius is again going to be under root 40. We have this as point C. Now, this angle can be a 30 degrees here, and this angle again, it can be a 30 degrees here, meaning at the center, angle PCQ will be equal to 180 minus twice of 30 degrees, meaning this angle at center shall be equal to 120 degrees here. So to get the area, I should say it's the area of PCQ. That should be equal to 1 by 2 into the two adjacent sides, PC and CQ, into sine of the inclusive angle, which in this case is PCQ. For those of you who do not remember this diagram, this formula, just remember that if you are given the area, if you are given a triangle with two adjacent sides, like let's say it's A and B known to you, so we can find the area by saying that the area is equals to 1 by 2 into the lengths of the two adjacent sides multiplied by the sine of the inclusive angle, which in this case is ACB. So I have CQ, I have PC, both are the radii here. So I can say that the area is going to be 1 by 2 into under root 40 into under root 40 into sine of 120 degrees. So this can be equal to 1 by 2 into a 40, and sine of under root 120 is going to be under root 3 divided by 2. So my answer is going to be 10 under root 3. The other two triangles, the area for them shall be the same. So I should say that the area of the equilateral triangle PRQ shall be equal to 3 times 10 under root 3, or I can say it's a 30 under root 3 unit square. So this can be done by applying simple trigonometry to the question. So the third question that we have now is from year 21, winter, and it's the variant 3 from paper 1, and the question says that the line y equals to x plus 5 intersects the circle equation with x squared plus y squared equals 20 at A and B. So find the coordinates of A and B in surd form, this is important, and then hence find the exact length of the chord AB. So I have the line equation with equation as y equals to x plus 5. I have the circle equation, which is x squared plus y squared, and that equals a 20. I need, with respect to the circle, we can just say that there is a line with gradient 2x plus 5. Let's say that's the line which represents y equals 2x plus 5, and the center of the circle, obviously it's x squared plus y squared, then that means that the center needs to be at the origin, and the radius shall be under root 20. So this is one thing that I know from the given equation. And the circle and the line intersect at points A and B. We need to find the coordinates of A and B, and then we need to find the length of AB. So the two equations need to be solved simultaneously. So I will be equating the line equation into the circle equation so that this becomes x squared plus 2x plus 5 the whole square, and this is equals to a 20. Or it's an x squared plus 4x squared. I'm applying the algebraic identity a plus b the whole square, which gives me I'm just writing it here again, a plus b the whole square, which is a square plus 2ab and a plus b square. So it's a 4x square plus it's going to be a 40x plus this is going to be a 20x plus 25 and a minus 20. This is equals to 0. Or this becomes a 5x square plus 20x plus 5, which is equals to 0. Taking 5 common, I'll be left with x squared plus 4x plus 1, which is equals to 0. I want to give the coordinates of A and B, and also they need to be in the surd form. So to do that, I can just apply the quadratic formula, which is a minus b plus minus under root b square minus 4ac divided by 2a. I know that a is the coefficient of x squared, b is the coefficient of x, and c is the constant. So it's a negative 4 plus minus under root 4 the whole square minus 4 into 1 divided by 2 times 1. Solving it further, this becomes a negative 4 plus minus under root 16 minus 4 divided by 2, or I can say it's a negative 4 plus minus under root 12 divided by 2. So under root 12, for that take LCM of 12, and with that this becomes 2 6 2 3 and 3 1 Therefore I can say that under root 12 shall be equal to 2 under root 3 here. So substituting that 2 under root 3, I can say it's an x, which is equals to minus 4 plus minus 2 under root 3 in place of under root 12 divided by a 2. 2 can be taken common. I'll be left with the minus 2 plus minus under root 3 divided by 2, and the two coordinates for a and b are negative 2 plus minus under root 3. So these are the two x coordinates of a and b. Now for the y coordinates, the equation for y was a 2x plus 5. So I will be substituting this in y equals 2x plus 5, which is the original equation of the chord or the line. So if I substitute that, this becomes 2 times negative 2 plus minus under root 3 and then a plus 5. So I will be solving it twice, once with the negative sign and the other with the positive sign. Second is going to be a minus 4 minus 2 under root 3 and a plus 5 here. So my answer is going to be a 1 plus 2 under root 3, and it's going to be y, which is equals to a 1 minus 2 under root 3. So I can just give the coordinates of a as a negative 2 plus under root 3, comma 1 plus 2 under root 3, and the coordinates of b as minus 2 minus under root 3 and 1 minus 2 under root 3. So these are the coordinates of a and b. Now I need to find the length of AB. And by the distance formula, I know that the length of AB shall be equal to the difference between their horizontal or x coordinates and the square of it, plus the difference, the squared difference between the y coordinates and the square, and definitely under root. So this shall be minus 2 minus under root 3, the x coordinate of B, minus 2 plus under root 3 and the whole square, plus 1 minus 2 under root 3 minus 1 minus 2 under root 3, and obviously the square of this also, and obviously the answer that we get should be taken as the under root sign. So solving it further, I should be getting AB, which is equals to under root minus 2 under root 3 the whole square, and a plus minus 2 under root 3 and minus 2 under root 3, that would give me a negative 4 under root 3 the whole square, and that would give me a 2 square, which is a 4. Negative becomes a positive because negative into negative is a positive. 2 square is a 4. Under root 3 into under root 3 is just a 3, plus 16 times 3, and my answer is going to be a 12 plus 48, or I can say that my answer is under root 60. Or solving it further, I can just take the LCM of 60 if I want to give it in a proper surd form. I can say it's a 2 times 30, 2 times 15, and it's a 3 and a 5 and a 5 and a 1. Therefore, my distance AB can be given as a 2 under root 15. So this is what the distance of the chord from A to B is going to be. So the second part says that there is a straight line through the point which is 10, 0. So there is a point on the tangent which is 10, 0, and it has the gradient which is m. So it's a tangent to the circle, so find the two possible values of m. So from here at least I can get the tangent equation, and I can say it's a y minus 0 which is equals to m times x minus 10, or I can say it's y which is equals to m times x minus 10 here. So this is the tangent equation on the given circle with equation x squared plus y squared equals a 20. So I have my y, I can substitute this y in the circle equation so that it is x squared plus y squared equals a 20. And substituting the y in the equation, I will say it's m times x minus 10 the whole square, which is equals to a 20. Solving it further, I can say it's an x square plus m square and x minus 10 the whole square, which equals a 20. Solving it further again, it's x square plus m square into x square. Now I'm going to apply the algebraic identity, which is a minus b the whole square, that is equal to a square minus 2ab and a plus b square. So it's going to be x square minus 20x plus 100, and 20 taken on the left side becomes a negative 20, and the entire equation will be equal to a 0. So it should be x square plus m square x square minus 20 m square x and a plus 100 m square minus 20, which is equals to 0. So I know that the line is a tangent to the circle, and I have obtained a quadratic equation, which takes me back to the concept where it says that to a quadratic equation, if there is a tangent, then the discriminant condition should be for b square minus 4ac is equals to 0. So a is the coefficient of x square. In this case, it's going to be 1 plus m square. B is the coefficient of x, which is going to be a minus 20 m square, and our c is going to be a negative 20 and 5m square minus 1. So if I substitute all the values in the discriminant condition, this becomes minus 20m square the whole square minus 4ac, so that means it's minus 4 times 1 plus m square, and c, which is a minus 20 times 5m square minus 1, and this will be equal to a 0. So my substitute a, b, and c in the discriminant, I shall be having minus 20m square the whole square minus 4 into 1 plus m square times 20 into 5m square minus 1. Negative 4 times 20 is a minus 80, bracket 1 plus m square, bracket 5m square minus 1 equals a 0. I'm taking 80 common. So with that, I'm left with the equation, which is 5m to power 4 minus 1 plus m square and bracket 5 minus 5m square minus 1. This shall be equal to a 0 then. So if I do the expansion, it's going to be a 5m square minus 1 plus 5m to the power 4 and a minus m square. This shall be equal to 0. Or I can say it's a 5m to power minus 4 minus 5m square plus 1 minus 5m to the power 4 and a plus m square. This is equal to a 0. 5m4 minus 5m4, they get cancelled. I will here be left with minus 5m square plus m square, which gives me a minus 4m square and a plus 1, which equals a 0, or 4m square, which equals a 1. Or I can say it's a negative 4m square equals a negative 1. 1 is taken on the right side, the negative gets solved, and I will be left with m square, which is equals to a 1 by 4. So to get the value of m, I will take square root on the right side. So my answer for m is going to be plus minus 1 by 2. This is going to be the two values of m for the given condition of the circle and a tangent. So this is how this question will get solved. So the next question that we have is from summer 2022, and it's variant 1, question 9. And it says that the equation of the circle is x squared plus y squared plus 6x minus 2y minus 26 equals 0. Find the coordinates of the center of the circle and the radius, and hence find the coordinates of the lowest point on the circle. So let's start working on it. To get the center and the radius, we are doing part A. So the circle equation is x squared plus y squared plus 6x minus 2y minus 26. This is equal to 0. So let's arrange so that this is x squared plus 6x plus y squared minus 2y, and we have a minus 26, which is equal to 0. So for completing square form, it should be the 6 divided by 2 and the 2 divided by 2 again. So 6 divided by 2, that gives me a 3. So I should go for 3 the whole square and balancing with negative 3 the whole square. 2 divided by 2 would give me a 1 the whole square, and doing the balancing, it's negative 1 the whole square. So I can say that this is x plus 3 the whole square plus y, middle term sign is a negative, so y minus 1 the whole square, and minus 3 the whole square, which is a minus 9 minus 1 minus 26, which is equals to a 0. Or we can say this is x plus 3 the whole square plus y minus 1 the whole square, and it's a minus 36, which is equals to 0. And further, we can say it's x plus 3 the whole square plus y minus 1 the whole square, which equals a 36. 36 is a perfect square. Therefore, it's x plus 3 the whole square plus y minus 1 the whole square, and this is equals to 6 the whole square. That can give me a 36. So the center points are going to be negative 3 and a positive 1, and the radius of the circle is going to be 6. So these are the two things that were asked in the question, and hence find the coordinates of the lowest point on the circle. So if I just make the sketch, with C as -3 and a 1 and the radius as a 6, then this can be the lowest point on the circle. Just below the center, I can have the lowest point on the circle. So obviously, the x coordinate will not change. It's a -3. The radius is a 6, meaning from 1, I shall be moving down by 6 units. I shall be moving down by 6 units. So yc minus ya should be equal to 6, and which is the radius. Yc is a 1 minus ya, which we actually do not know. This is equals to 6, or I can say it's y1 minus 6, that should be equal to ya, or the y coordinate of the lowest point on the circle should be a -5. So the lowest point on the circle should be having the coordinates as -3 and a -5. So this should be my answer to the question here. So the second part of the question from summer 22, paper 1, variant 1, that says find the set of values of the constant k. We need to have the values of the constant k for which the line with the equation y equals kx minus 5 intersects the circle at two distinct points. So the line intersecting the circle at two distinct points, that gives us the discriminant condition, which says it should be b square minus 4ac, that has to be greater than 0. That is the condition for two real and distinct points. So that means we have to solve the two equations simultaneously. From part 1, we got the circle equation, and the circle equation was x plus 3 the whole square plus y minus 1 the whole square, which equals 36. This was the circle equation. It's the equation of circle. And we have the line equation, which is y equals kx minus 5. I can just plug in this y as kx minus 5 in the circle equation to get our equation in terms of x. So I can say that this is x plus 3 the whole square plus kx minus 5 minus 1 the whole square, and this is equals to a 36. I have the entire equation in terms of x. So now doing the expansion with respect to a plus b the whole square, or solving it further, I can say this is x plus 3 the whole square plus kx minus 6 the whole square, which is equals to a 36. So doing the expansion for a plus b the whole square, which equals a square plus 2ab plus b square, and for a minus b the whole square, this needs to be a square minus 2ab plus b square. So my equation becomes x square plus 6x plus 9 plus k square x square minus 2 times 6, that gives me a 12 kx, and a plus 6 square, which will give me a 36, and this is equals to a 36 again. So the 36 on both the sides, they get cancelled. So I am here left with x square plus k square x square. I'm just arranging all the x's on one side, all the x squares, all the x's, and then I am left with the constant, which is a 9. This is equals to 0. So I can take x square common to get the coefficient as 1 plus k square. That becomes the a value for the discriminant. Then I can take 6 common, so that I'm left with 1 minus 2k times x, and then I will be left with the plus 9, which is equals to 0. So from here I can say my a value is a 1 plus k square, a is the coefficient of x square, b is 6 times 1 minus 2k, and then c will be equal to 9. So applying the discriminant condition, I should say that my b square minus 4ac will be greater than 0. So that gives me 6 times 1 minus 2k the whole square minus 4 times 1 plus k square, and then c, which is a 9, and this needs to be greater than 0. So if I solve the equation, I will get a 36 times 1 minus 2k the whole square minus 4 nines are 36, and then 1 plus k square, which should be greater than 0. So what I can see here is that I'm getting a quadratic equation with the coefficient of k square, which is a positive. Let's solve it further and then compare it with and then get the k values here. So 36 can be taken common. I will be left with 1 minus 2k the whole square minus 1 plus k square bracket, and this shall be equal to 0. 36 gets eliminated. I will be left here with 1 minus 4k plus 4k square minus 1 and a minus k square, which should be equal to a 0 here. So this gives me 4k square minus k square, that gives me a 3k square and a minus 4k, and 1 and negative 1 also get cancelled, and this is equals to 0. Now I have this quadratic equation in terms of k with the coefficient of k square as a positive, meaning I will be having the curve here and then comparing it with the x-axis. I have two values of k. One is k common. I will be left with 3k minus 4, and the k values are going to be k equals 0 and 3k minus 4, which is equals to 0, from where I will get k is equals to a 4 by 3. So k is a 0 is one point here, and 4 by 3 is the other point here. Now if we go back to the discriminant condition, it said it needs to be greater than 0. If I just underline it, it said that the discriminant condition was supposed to be greater than 0. So if it is greater than 0, we are talking about the region which is above the x-axis. Therefore, I can say that my k value should be all less than 0 and it should be greater than 4 by 3. So I can say that k is less than 0 or k can be greater than 4 by 3. And then this is going to be the answer for the set of values of k that we were supposed to find here.